At first, you wouldn't
Zuerst
anything. And then, suddenly, everything would change. Radically and violently. Imagine yourself 500 years in the future. You're sitting in a ship, zipping through the silent, empty void of outer space. You're traveling to explore a black hole up close for the first time in human history. You're very lucky to be able to do this. For centuries, the prospect of traveling to a black hole was absurd. The closest one is nearly 60 million billion kilometers away. But great advancements were made in space travel and cryogenics, and here you are. You're traveling to a black hole. And you're about to make a very big mistake. But we're getting ahead of ourselves. What is a black hole? Everyone here is either sitting down or standing, and one person lying down over here. That might not sound like a profound statement, but cosmically, it kind of is. And no matter who you are, no matter your gender or skin color, in moments like this, moments of extreme strife and stress and hardship, it's important to keep in mind that no matter who you are, you all have one very important thing in common. You're not currently floating around the room. Why are you not floating? Because of gravity, of course. Gravity is the force of attraction between any two big objects, like between the moon and the earth, or between the earth and you. But gravity isn't just any old force. Gravity does what it does because the presence of a large amount of stuff within a certain volume of space creates a kind of sinkhole in space itself. But wait a minute. Stop right there. You've probably heard a variation on something like that before in your life. What does that mean? What does it mean when we say that gravity is what happens when you create a kind of sinkhole in space itself? Surely space is just space, right? Space is not a thing. It's the absence of something. It's a void. It's an emptiness. So what is space? When an apple falls from a tree, what is it falling through? Well, the atmosphere. But what about the moon? As the moon orbits the Earth, what is it falling through? Nothing. Space. And for the longest time, this is what we thought about as space. Space was obviously not a thing. It was more or less like a background. It would be sort of like the chalkboard upon which you draw something you're interested in. So, for example, if I draw a circle to represent a planet on a chalkboard, the circle is the thing I'm interested in. The chalkboard is just a background, yeah? For the longest time, this is how we thought about space. And clearly, space is like that as well, right? Wrong. It turns out that space, in fact, has a very, very strange property. The more stuff you pack into a given volume, the more space bends and flows toward the center of that volume. This is a completely different perspective on what space actually is. This thing that we thought about as sort of a background, a theoretical construct, actually can move and flow depending upon how much stuff happens to be there. Imagine what it must have been like to be the person to come up with that idea. Imagine what it must have been like. The people that came up with this idea had to completely ignore thinking superficially, thinking incrementally. They had to think big, and they had to undercut all of the fundamentals. Because it's been proven over and over since then. The more stuff you pack into a given volume, the more space bends and flows toward the center of that volume, until eventually, if you pack too much stuff into a fixed volume, space will be flowing toward the center of the volume faster than you could ever possibly travel. And this is a black hole. You can think of a black hole in space like an extremely strong water drain, where the water is the fabric of space itself. Imagine you're a fish in the water. If you get too close to the drain, the water will be flowing inward faster than you can possibly swim. And even if you swim at your fastest possible speed, you'll be sucked into the drain. Likewise, if you stay far enough away from a black hole in space, you're okay. But there's a point of no return called the event horizon, beyond which space is flowing into the center faster than the speed of light. Forget about your spaceship, not even light can escape from inside of a black hole. And unlike a water drain, if a fish got too close to a black hole in space, the gravitational conditions would be so severe that the gravitational conditions on the tail would be so much greater than those at the head, the fish would probably be stretched into something resembling fish spaghetti. Something a little bit wonky with the slides here today, that's okay. Because not even light can escape from inside of a black hole, we can't see them directly, of course, but we can see stars orbiting completely empty spots in space. And as of 2019, we can see the hot gas swirling around black holes in images like this one, just released a few weeks ago, of the hot gas swirling around the black hole at the center of the Milky Way. This is the cosmic vortex that holds our galaxy together. And black holes are everywhere. The universe loves these twisted vortices. There's a big one at the center of nearly every large galaxy we've observed, including our own Milky Way. And they're scattered, in fact, throughout and among the stars in our galaxy as well. The closest known confirmed black hole is about 6,000 light years away. Given that the galaxy is 100,000 light years across, that's not that far. And in fact, there could be a mysterious black hole even shockingly closer to Earth. In the outer edges of our solar system, several big rocks seem to be orbiting in strange ways. Some astronomers think that there could be a new planet, Planet 9, that could be responsible for these odd wobbling orbits. But we see no evidence of a visible planet. So maybe the reason we haven't seen it is that it's not a planet, but is a black hole about the size of an apple that was formed not long after the Big Bang and then floated around our galaxy for billions of years before finally getting stuck in our solar system. So, an apple-sized black hole, heads up. An apple-sized black hole. Can you make a black hole yourself? If you want to know the density it takes to make a black hole, simply grab your textbook on gravity. I assume you all have a textbook on gravity on your bedside table like I do, and find the black hole equation. It'll tell you, for some given amount of mass, the size of the volume you need to pack it in to make a black hole. For example, if you wanted to make a black hole out of the Earth, you'd need to pack the entire thing into a volume about the size of a blueberry. Most black holes we know of are much larger than apples or blueberries, of course. The black hole at the center of our galaxy has a diameter equivalent to about 1/3 of the distance between the Earth and the Sun, but with a mass 10 million times that of the Sun. And there are black holes much larger than that in other galaxies, with masses tens of billions of times that of the Sun, and with volumes that would encompass our entire solar system. So this is all very well and good, but how do black holes come into existence? How does the universe make something so dense that it nearly punctures the fabric of space-time? Well, one way is when an enormous star dies. After billions of years, a star can exhaust the fuel it needs to burn, and in one final hurrah, explode. It's supposed to explode. I don't know what's going on. I think some of the animations got ruined here. This is really unfortunate. Let's see if I can try this again. Nope, not going to work. So in one final hurrah, explodes. And with no more gravity to push it outward, with no more nuclear reactions to push it outward, gravity wins, and the whole thing collapses in on itself. And this collapse can be so severe that it creates a black hole. So you can see that it takes a pretty violent event, like an enormous star dying to make a black hole. So is it possible that we could make black holes where I work, at the Large Hadron Collider at CERN? The Large Hadron Collider is a 27-kilometer circular tunnel on the border of France and Switzerland. And in this tunnel, we take tiny particles and we accelerate them to almost the speed of light. And then we smash them into each other at the highest energies that humans have ever used in such an experiment. This is also not working. It's supposed to be a little bit of a clip here. I think we got the wrong file. Give me 1 second here. Yeah, we'll just let it run. At the highest energies that humans have ever used in a collider experiment, at the smallest possible level, as you'll see in a moment here, these collisions are a pretty violent event. And it's theoretically possible that we could make tiny modified versions of black holes that would evaporate immediately. This would be phenomenal, despite the looks on some of your faces, because the real reason we physicists are obsessed with black holes is that they could help us answer one of the most baffling and long-standing questions in science, the mystery of how gravity and quantum mechanics work together. In physics, we have two fantastically good theoretical models that have withstood essentially all of our experimental tests. The first is called general relativity, which describes how gravity works on very large scales. The other is called quantum mechanics, which describes the world of the small. Each of these by itself ranks among the most impressive intellectual achievements of humankind. But there's a problem. When we try to naively combine these two theories, hoping for a more fundamental theory of the universe, everything breaks. We get nonsense answers like infinite energies or probabilities greater than 1. When this happens, this is the universe's way of telling us to think harder. We suspect that far back at the moment of the Big Bang, some kind of quantum gravity must have existed. And in the current universe, the place where these two theories collide is in a black hole. So studying a black hole up close in the laboratory would shed monumental light on the subject. Alas, we see no evidence of miniature black holes at the Large Hadron Collider yet. But maybe we just need a bigger and more energetic collider. Discussions are currently underway for the potential successor to the Large Hadron Collider, the Future Circular Collider. Presumably they'll change the name when the future becomes the present, which would be 100 kilometers around and could reach energies 7 times that currently achieved. But would that be big enough? Maybe quantum gravity is waiting for us on the moon, where the Large Hadron Collider is 27 kilometers around. A collider encircling the moon would be 11,000 kilometers around and could reach energies 1,000 times that currently achieved. So let's recap. I'm standing in front of you and I'm telling you we should build a collider that encircles the entire moon sometime in the 22nd century to make black holes? Am I crazy? Well, after talking about this concept for several years in a kind of inspirational, sort of rough, vague way, just last year, a colleague and I actually wrote a paper about this prospect, and it turns out it's not crazy. There are no showstoppers to building a collider around the moon. All the scientific and technological concepts are there. It's just a matter of development and scale. A circular collider on the moon sometime in the 22nd century might seem impossible, but it's not impossible. It's regular impossible. And regular impossible we can do. Regular impossible is only impossible right up until the moment someone makes it possible. But will that be big enough? I like the way you think. No. The larger the collider, the higher the energy until you reach a kind of an ultimate energy known as the Planck energy, Max Planck. The Planck energy. And this is the energy at which gravity and quantum mechanics must have something to do with each other. However, by some naive estimates, to reach the Planck energy in a collider, we would probably have to build one like the Large Hadron Collider that circles around the outer orbit of Neptune. And I see that this has been nicely ruined here in translation. So the blue line is supposed to very dramatically appear past Neptune. Imagine that's what happened instead. Clearly, we're going to need some major innovation to make such a collider happen. And by that time, our civilization, once it's finally advanced enough to build such a superstructure, will probably have advanced enough to master interstellar space travel. And at that point, 500 years from now, you will be in your spaceship traveling to a black hole. One day, in your ship, you get tired. You note that you should arrive at your destination in about 12,000 years, so you decide to take a 12,000-year-long nap. And as you lie down on your cryogenic bed, you very slightly bump your ship's accelerator. You don't even notice. After 12,000 years, you awake, fix yourself a cup of coffee, and you notice from your gravitational sensor that something is very wrong. You seem to be too close to the event horizon of your black hole. You look out the window and you see an enormous, profoundly black disk in space. The light from the stars and galaxies behind it twisted and deformed. You stare into the center of this disk, a cosmic eye staring back at you, and it's the emptiest thing you've ever seen. Your jaw drops and your eyes widen, and then you realize that you're not sure if you've passed the event horizon, the point of no return, yet. You double-check your gravitational sensor, and it says you're not there yet. You have 5 seconds to blast away. You leap from your chair, leaping toward the controls for your rockets, spilling hot coffee all over your hands. You scream and fall to the ground, and by the time you get up, it's too late. You're passing the event horizon of a black hole. You nearly stop breathing. Your mouth feels like sand, and you close your eyes. You can't believe that this could possibly be happening. You open your eyes and look out the window again, and everything looks about the same. The ominous black disk is getting a little larger, maybe, but otherwise, you don't feel any different. You feel the same. You think maybe your estimate was wrong. Maybe there's still a chance to escape. You triple-check your gravitational sensor, and it says that no matter which direction you point it, you are pointing toward the center of a black hole, and then you know for sure. You've passed the event horizon. You are inside a black hole? A calm terror settles over you. How did you get in this situation? For years, while you were asleep, the conditions of the universe around you were changing, nearly imperceptibly, and then suddenly, it was too late. Floating in your spaceship inside of a black hole, what do? You might start thinking of possible escapes. I mean, maybe it's possible that all the clever scientists were wrong, and there's some way to escape that hadn't been anticipated. You start fantasizing that maybe if you just get lucky or you just wait long enough, the situation will sort itself out, and you will eventually pass back over the event horizon and could zoom away from the black hole, back to the universe you once knew, back to the way things were. And as you're fantasizing, you look down and you see that your shoes are floating away from you, and your legs are being stretched into long, thin, spaghetti-like strands. And then suddenly, your feet are so far away that you can't see them anymore. And in that split second, before you reach the center, you realize 2 things. One, that no one really knows what happens in the center of a black hole. And 2, there is no going back to the way things were. The only way out, if there is a way out, is directly through the black hole. Sometimes reality becomes twisted, seemingly beyond recognition. And right now, as the planet burns and the global temperature rises, and as large-scale war waged by a fascist has returned to Europe for the first time in almost 80 years, and as so many of our fellow humans are dead because of a mismanaged pandemic, while so many others allow themselves to be duped by pseudoscience and disinformation, right now, you'd be forgiven for thinking that we'd fallen into a societal black hole. In retrospect, it happened so slowly, nearly imperceptibly, while so many of us were asleep. And then it was too late. But just like in a black hole in space, the only way out is through. Our current societal black hole is a golden opportunity to construct a better world and to think in radical new ways to do so. But we can't be superficial. We can't think incrementally. We have to dig deep, and we have to think big. Question the fundamentals, and we have to think big. For example, there's more than one reason why we should consider building a particle collider on the moon. The first reason is scientific. Such a project would teach us incredible things about the universe, full stop. But the second reason is existential. Our society is addicted to repeating its mistakes. And right now, we seem to be on the verge of simply giving space and Mars and the moon to wealthy private individuals and corporations whose only interests are extraction, exploitation, and profit. This is bad. Because this extractive mindset here on Earth has led to the destruction of the environment due to anthropogenic global warming. If we simply repeat the same mistakes in space that we've made here, that's bad. So projects like a circular collider on the moon, projects mounted solely because our species is curious about the universe, and it doesn't have to be a collider, there's lots of other scientific projects. Centering such projects would remind the world that the moon belongs to everyone, instead of encouraging a moon rush where wealthy private individuals or private interests compete to see who can be the first to extract moon minerals or who can be the first to build a luxury lunar wellness spa for billionaires. The moon should be protected in perpetuity against commercial exploitation. And thank you. And centering projects like this, projects mounted solely because our species is curious about the universe, would remind us, as I said, the moon belongs to everyone. But dig deeper, think even bigger, question even those fundamentals, just like the first people 100 years ago who finally realized, more than 100 years ago, finally realized that space was not empty, not the thing that we thought it was. The problem we face now is not just a few narcissistic billionaires. Why do billionaires even exist to begin with? How did we allow ourselves to develop and maintain systems that result in a few dozen individuals holding as much wealth as billions of the rest of us combined? And why do we allow the beneficiaries of these systems to convince us that such systems are inevitable, as if they're laws of physics? Keep in mind, gravity creates black holes, and gravity, simply a law of nature. But the social, political, and economic structures that lead to extreme wealth inequality, racist policing, the climate emergency, are not laws of nature. They're human-made, which means they can be human unmade. We owe it to future humans to finally find the courage to unmake these structures, because of course it won't be you 500 years from now traveling to a black hole. It's up to us to ensure that the earth itself and our society are not crushed into oblivion. And it's up to us to fix our social inequities so that your great 25 greats granddaughter can push forward into the unknown to better understand humanity's place in this vast universe. Thank you. Thank you. Thanks.